So this is part of the C++ Core C++ conference, co-hosted event, teaching C++. We will join later today the closing keynote of the Core C++. So please be with us right after the two sessions, my session now and Yechezkel Bernat. The two sessions now will speak about C++ 11, C++ 14. This is me. And then Yechezkel will talk about C++ 17 to 20. I guess my talk is more relevant for what we teach today. But it is very important to note and think about what we should teach in the future, take this into account. In some cases, we mentioned that in our lectures that in C++ 20, things will change. Things will work otherwise. You will do it in a bit different way. So I think both lectures are important for teachers. I know that some of you do not teach. I mean, everybody teaches every day, even if he's not a teacher. But I mean, you are not a full-time teacher by your job. And still, it is important for us to get your inputs, to get your feedbacks if you come from the industry. If you interview people, what you are looking for C++ juniors, and we'll have a lecture on that also tomorrow. So I'm going to talk about the features in C++ 11 and C++ 14. And the talk would not cover all the features. It's not a checklist. It's not a list of all features in C++ 11 to C++ 14. There are checklists like that. There are feature lists on the web. I will dive into very few items, but the main idea is to, in a way, share with you the experience of teaching C++ 11, C++ 14 to students. So I will cover features, I will cover things that I teach, and the way that I teach them, or what I'm talking in class, and the experience of the students when they see that. So, a few words about myself. My name is Amir Kirsh. I teach here at the Academic College of Tel Aviv, Yafo, since 1998. I was very young there then. And I teach also in Tel Aviv University. In both institutions, I teach C++. I was working in the industry for a few years, being the chief programmer in Converse. There was a company called Converse back then, and we were doing a lot of C++ also. So I'm coming with some industry background that let me understand what the industry is seeking when employing juniors, and this is something that I try to bring with me to class. The language is evolving. This is the chart that I took from the ISO-CPP website. The chart itself is changing also. So if you look at it tomorrow, it might be a different chart. I'm taking the chart to my slides. And every time that I take the chart, it is a different chart. I go back to previous slides and I say, hey, it's not the same chart that I took a few months ago. Because things evolve, and even what would go into C++ 20 is something that is being closed during these months. But we know what is in C++ 11 already. And the idea or the notion that this is a living language and there is evolvement is the reason I think that we have here a conference with more than 300 people from Israel and abroad coming to hear about C++, because C++ is live and kicking. And I think 10 or 20 years ago, we would have less people in a C++ conference. There are new projects using C++, and this is the reason, because the language is evolving. But then we need to teach the evolving language. We cannot teach the old language. So we have to start with the very basics. And the very basics with C++ 11 start with new ways to initialize objects and std initializer list, and both together. And you then see that when you want to create a thingy, you can create a thingy with curly brackets. Why with curly brackets? To avoid the most vexing parse, right? So maybe you heard about the most vexing parse. If not, you know that Wikipedia has an entry on most vexing parse. It's so important that it is in Wikipedia, okay? Now students, if they don't believe, I ask them, okay, try to write that with round brackets. And we see, okay, curly brackets do something. It behaves differently. But it doesn't end there. Because curly brackets means also different narrowing conversion rules. Why? Because the language decided so. In some cases, the students they like to ask, why? And in many cases, my simple answer is because the spec says so. And then, it ends there. And this is why. In some cases, we do discuss why the spec decided to do something in that way, okay? But we don't have the time for that always. So in many cases, I just stop it by that. But then when initializing with std initializer list, it shares the same syntax, but the different behavior. So if you look at the following lines, there are 3 lines. What is the difference? I will let you think about that and would not solve it now. But I think this one is easy. Okay, there is a difference between allocating int without any brackets or allocating it with curly or rounded brackets. But then when we come to other cases, we may find that we have 4 different cases, okay? The font is a bit small there, so you have to make an effort to focus with your eyes. There are 4 std vectors there, all 4 are on int, and all are initialized with some integer value. The first 2 are initialized with 2, the number 2, one with rounded brackets, the other one with curly brackets, and then we have 2 other std vectors initialized with 2 ints. One is initialized with curly brackets, and the other one is initialized with rounded brackets. Okay? How many different behaviors do you think you will have here?
4.
So Meir says 4. You are exaggerating, right? No, he's right. Okay, so 4 different behaviors for something that looks like at least these 2 should be the same, and these 2 should be the same, but they are not. So I leave you the exercise at home or during the break. Okay, you can stay at class during the break and check on an online compiler what is the actual behavior of each of those. Okay, now students look at that, and you still have the mission of getting them to love C++.
Especially if they are coming from Java.
And no wonder it takes only the crazy ones, which we meet later at the conferences and meetups, or the unaware ones. But we still have to get them love C++. Otherwise, why should we teach them C++ if they are going to program in Java after that? So okay, we need to teach them that this is how the spec decides, and that's not so. Okay, just use it as it should be. And then we come to auto, and we say, okay, auto can help you deduce the right type of variables without saying the type yourself, and it is nice because, I don't know the type. You are the compiler. Tell me the type. It's nice. And I still have to say that the language is still statically typed, and they understand that. And some of them already know JavaScript, and I'm saying, or Python, and I'm saying, no, we are not a scripting language. It didn't change the language. We are still statically typed. And then I have to discuss when to use it and why, okay? And there are different opinions here. And it's nice to hear what they think. Different opinions also in the industry. Who says use it always? Almost always. Well, the big shots of C++ say, the big shots, I mean, Elb Sutter, Bjorn Stursap, Scott Myers, they say use it almost always. On the other hand, a big company that you know that say, don't use it too much. Well, the Google style guide is saying don't use it too much. So there are different opinions here, and students do have their own opinion, and I also have mine. But eventually, okay, they have to decide whether they love auto or not, okay? So after all, auto can help us.
Not everybody saw that.
Yeah, not everybody saw, but we had here, it's a geek conference, okay? So we have geek shirts. So yesterday I had another shirt with auto saying something else, but today I'm with I love auto. So the question is, okay, is it a good thing? Yeah, it's a good thing. It's mostly a syntactic sugaring thing, but it may have efficiency effect. I think that the spec doesn't define, or I don't know, maybe Wikipedia or any encyclopedia defines what is syntactic sugaring. But in general, syntactic sugaring means that you could do the same before with the very same syntax, but with this syntax, it's nicer. It's not different. So with auto, it's nicer, and it is not different. So it's almost a syntactic sugaring, unless you would do that, but you would do that with a mistake. And
Do you want questions? Or
I think that we will delay the questions till the end if we will have time, or in the break, or if it is something very short, that maybe we'll go for a question.
I just wondered if you can relate to a more template generic.
Yeah, sounds like a long question. So we'll delay it to the end. Okay. But I have students like that. It's not something new for me. It's okay. You're a good student. So deducing the variable is nice, but the question is, would it deduce it better than I? And the answer is yes, and this is why it can have efficiency effect. And the students, in some cases, do not believe that. And then I do a small program with them, which looks like that in an online compiler, okay? They see this size of font, but we are a bit older than them. So I will just raise the size a bit. And increasing the size a bit more, maybe? No, it's fine. So what I'm showing them is, do you know the very basic example of comparisons, comparing auto deduce to another thing, showing that auto deduce the right type, while if you would do that, most probably, or in many cases, I found cases like that in the industry, in places that work very hard on performance, and then right under they see, we do here tons of copies redundantly. And they put many efforts on performance. So it's a very, it's a known example. And the example is running, iterating over a map. What is the problem here? What is the bug, I would say, even? We are iterating over a map. We want to get back by reference because we want efficiency. We take back the pair. Because we don't want to change it, we take back the pair as const. And the bug, and it does compile. And I'm saying you that there are copies here. Suppose it's a pair not of person to int, a Godzilla to int. And you get copies of the person or the Godzilla. How come? Because what comes out of the map is not this type. It's another type that can be converted to this type. Now, hey, can I convert thing to a reference? Not to L-value reference, but yes, you can convert something to a const L-value reference. And this is what's happening here. You convert the pair of const person to int to a pair of person to int, and this conversion creates a new person. So you actually copy all the persons that get out together with a pair that you have to create in a loop that you thought only brings the reference from the container. And students do that. If they do the right thing in their eyes, they say the correct, to reach the point that they know to express this type is a real celebration. And then you say, no, don't do that. Auto is better. But yeah, you have to, in a way, ruin their celebration. And it's not so bad because the same mistake is done, as I said, in the industry. And the correct thing to do is either to do it with auto, like here, okay, like above, and then it works fine because auto deduces the correct type, or to write the correct type. You can say just, okay, this is the correct type, but how can you remember that? You would not. And it's a long type. Okay, so when I show that to students, they are convinced that, yeah, auto is more than just syntactic sugaring. It is syntactic sugaring at the end because, you know, instead of writing auto, I could write the correct type. Yeah, but I'm not sure that I would deduce the correct type because compiler takes 6 years of compiler school, and we are taking only 4 years of CS. Let's let the compiler do their work. Okay. After I'm convincing that auto is fine, use it. And it's okay if you do not use it everywhere, but use it where you think you should, like for iterating over pair in map. Then we go on enums that you have in C++ 11 class enum to have a context for your class, for your enum constants. And then we go to const expression. And they understand that const is nice, but const is not strong enough because const says it is const, but it does not say that it is known at compile time. It's easy. They see that. And then we talk about const expression functions, because maybe you want to get your const expression value from a function, but then the function needs to be const expression. But if the function says that it is a const expression function, and you send to it I and j, can the actual result be also const expression in the last line? The last line is doing const expression, int, result, get the assignment of calling foo with I and j. Can I call foo with I and j and get back? And foo was declared as const expression function. Now, const expression function means that it might be const expression if I send to it const expressions, but it might not be if I just use it with variables which are not const expression. Can the last line compile? Only if I and j are const expression. Yeah, that's true. So if I and j are also const expression, then yes, it compiles, it's okay. This is a const expression, calling a const expression method function with const expression parameters. Okay, so they get it right. Sivan was also my student, he got it right. And range-based for, we go to that. And then we see that we can loop over arrays. It's nice. They ask, can we loop over an array that we got as a parameter to a function? And the answer is, can we get an array in a function and then use range base 4 to loop over the array that we just got? And the answer is, no, you cannot. You have to know its size, and you know its size only in the scope that the array was declared in. Okay, so when you pass array to a function, you actually pass the pointer, the address of the array, and they understand that. And then we do use range base 4 to go through collections, which is very nice because then you do not need to use iterators, or you can delay the point of time where you do reach iterators. So they stick with you in the course more time. And you also use auto and const, and you even tell them that you can implement range-based for, support range-based for your own types, which is nice. Maybe you even have time to do that in class. And then you reach R-value reference, okay? And you have to be strong. And you tell them that the committee decided that ampersand is not being used enough in the language. Which is true. It's only for bitwise and logical conditions and get the address operator and defining a reference. But there is still room. They are thinking about maybe there is still room for additional reference somewhere, additional ampersand. But OK, we want the reference to be somewhere else. Let's add it somewhere. So what's the problem that we want to solve? And usually I'm starting with the problem that we want to solve. And the problem that we want to solve is that prior to C++ 11, there were inefficiencies in redundant copying of temporary objects. So when I have a temporary object, and the temporary object is being copied to another one, and the temporary object is going to be destroyed. But I don't know that. So the only possible way to do that is to actually copy, even though I may know as a programmer that is going to be destroyed. So when getting a return value by a return from a method by value, there is no other way to do that, but in some cases return by value, then I'm copying. Adding objects to the container, I'm copying. Now, it's true that the compiler itself has return value optimization and copy elision, and when we do programs in class and I want to show something, you know, in many cases, in a simple program, you cannot show that temporary object create copy. Why? Because of the optimizations. So what should we do? I'm using the compiler flag -f no elite constructors. And I have to be in C++ 14, not in C++ 17, because in C++ 17, what happens in C++ 17, Yechezkel? In C++ 17, copy elision is part of the language. Okay, the compiler is obliged to do that. So I want to show that in simple cases there are redundant copies. Now, I explained that in non-simple cases, in more complicated cases, the compiler cannot do the optimization, okay, because it cannot follow. It's not a static code analysis tool or something like that. It cannot follow how the object will travel. So in simple cases, the compiler does the optimization. In other cases, not. And I want to show how it works in simple cases. And this is why I put the -f no elite constructors. But don't do that only just to see things. You do want the optimization. Okay, so they understand, and I think they understand the rationale behind having our value reference to know, to identify, with the help of the compiler, that we have here a reference of an object that is about to die. So what can we do with a reference of an object that is about to die? So suppose that we have a frightening Godzilla, a factory that creates a frightening Godzilla, and the frightening Godzilla comes back from a method that creates it, and it creates it not as a allocation. It's not newly allocated object. It's a local object. So I get it back by value. Now, I know that it is going to be dead at the end of the statement because this one is a temporary object, and I prefer to, how would I say it politely, to steal it, okay, if I can, because I know that you are about to die. Please give me your assets. You don't need them. So this is what I want to do, and they understand that this is something that might be more efficient. And the way to do that is to have two different functions, overloading. It is valid overloading, two different kind of references. One is there. Remember, we are not using ampersand enough. We need to use it more. So the two ampersands. And they think that I'm joking at the first, especially if the lesson falls on April 1st. So yeah, there is a difference between the two methods, and they understand that. And then you have to go to this table. No other choice. You have to explain the overload resolution, how the compiler decides where to go. And it's not so simple, but you have to go through that. And you still have the mission to get student live C++. No wonder it takes only the crazy ones who come to conferences like this one, or the anywhere. And then you go to the rule of 3, which started with C++ 98. It's not something new, but it changed a bit because now you can do equals delete. Okay, this is the C++ 11 new syntax, which is nice. Okay, so they understand that if you have a destructor or your class is managing resources, first thing you have to do is to block the copy constructor and the assignment operator. And they are, by the way, very happy about that, because what I'm telling them that in the exercise, they do not have to implement copy constructor and assignment operator. They are allowed to block them unless they feel that they need them. okay? And of course, this is better than just leaving them if this is a not, if this is a class who manages resources. But it doesn't stop there, right? What comes next? The rule of 5, okay? So you have also move constructors. Move constructor and move assignment operator, and maybe you want the default, or maybe you do not want the default. And if you wrote one of the 5, then there is a rule of what happens to the others. And they have to know that because you will ask them about that in the exam. And there is also something about no except. There is also something about rule of 0 before that. This is important. In some cases, we don't have time, so we skip in class the important parts, but this is an important part. And in some cases, we skip that because, not much to teach about that. But the thing to teach here is that the best thing is not to have any destructor and any copy, any of the 5, okay? And it means that, okay, I'm using OOP in the right way. And it's important to talk about that and understand, because in the industry, we prefer to have classes that do not manage resources. So use string, use STD containers, use smart pointers. Don't manage your own resources. Let somebody else do that. And then we have to talk about move. Because if we want to implement the move operations, then they have to know how to use STD move and know the difference between implementing a move this way, which means I have a move that doesn't work, that do copy, or I'm having the correct way of doing STD move or doing move operation with STD move. And then when they understand that, I'm saying to them, wait, but you have to know that STD move doesn't move. So they ask, so what were we talking about previously? And I'm saying, it's not this one that did the move. It's this one that did the move. It was just an helper, okay? So why do we call it STD move? Because this is what the spec decided. Okay, this is how the spec decided. So STD move doesn't move, and okay, but wait. There is something else to say about move if no except. Well, you don't really have to know it. And when you tell the students that you don't really have to know it, it will not be in the exam. So part of them disappear, and it's okay, they will not interfere. And the others just open their ears because they want to listen. And that's nice, that's good. Okay, so you have to know something else about move if no except, or maybe you should, or shouldn't. So, okay, this would not be for the exam, also here in this class. There are some rules about how containers can move things if I create move operations with no except or without no except. So I explained that, and usually the smart ones do get it, okay? The others just decided not to listen. But wait, it's not the end, because maybe we need also to talk about STD forward. Well, we don't really have to discuss STD forward at this point of time. Why?
Universal references.
Because STD forward is more relevant to templates, right? STD forward becomes relevant when we work with templates. So it relates mostly to templates, which would be discussed later in the semester. But there is a student who insists. He heard from his sister, who took this course 2 years ago, that there is also something called STD forward, so he needs to know the difference now. And okay, eventually, you have feedbacks at the end of the semester, and every semester you get that the teacher doesn't answer questions in class. So you decide, okay, let's try to answer the question. What's the difference, and why do you have STD forward? And we'll talk about that when we'll talk about templates, but let's have a short answer, okay? 2 minutes answer. Why do we need STD forward? So you give a quick example for STD forward in class. Suppose that I want to forward something. Suppose that I got, and you have no other choice but to give the actual real example with templates. So we say, suppose that I have some kind of template that got a T parameter, and I want to forward the T parameter to some dispatching function that should get T. Okay, and I want to pass T the way that I got it. Okay, I got it. I want to dispatch it the way that I got it. It was R value. I want to dispatch it to forward it on as R value. I got it as an L value. I want to dispatch it to forward it on as an L value. And it sounds reasonable, okay? I managed to do it in 1 or 2 minutes, and he's happy for a moment. But wait. He then realizes that the previous slide makes no sense. He is a smart student. Here it is again. What's wrong here? Why doesn't it have any sense? I'm saying to the student that you need std forward because you got something, and you want to forward it on with the same reference type as you got it. Okay, but he says, wait, I don't understand it. It makes no sense. We get it as an R value. You can just pass it on with std move. He listened. He got the std move right. I could do std move because, I got something that looks like something that can be moved, and I just have to pass it on as std move. So I have to tell him, well, you are technically right, dear student. If it was indeed an R value, but it is not. It's a forwarding reference, also known as universal reference, a direct result of the reference collapsing rule. And now he is quiet. Okay? But it didn't really answer his question because at the end, I had to use some magic words that didn't really help him. So, well, I've warned you. We don't really have to discuss it now, right? Okay, what's next? What do we have else in C++ 11? So we have override. Override is good. Override, all students understand override, I guess. You give a very simple example, and they understand that putting override on a virtual method that I inherited from the base, I say something for the compiler. I'm asking the compiler, dear compiler, can you check on me, please? And they like it because they usually come to me and ask me, can you check my program, please? And I ask them, did you ask the compiler to check first? No, we want you to look at it first. So they like the compiler to check for them. That's nice. But then I have to talk about final maybe, and final is a all different thing. And I have to say, you know what? It will not be for the exam. Smart pointers. I said before, I start with the rationale. And the rationale for smart pointers is very easy, and they like it. They totally like it when they understand that we are going in a way to dismiss row pointers. They say, yeah, go for it. But then we come to std unique PTR, and we say, OK, you create a unique PTR with make unique, and then you do std move to pass it on to another one. And when you want to pass it to another method, you have again to do std move. And then they say, can we go back to row pointers? We like them. Movable but not copyable? What are you talking about? What is movable but not copyable? And how can we use it like that? I just show you. OK, so you have to park on it a bit. And when they feel a bit secure, they say, we think we got it. 50%, OK, we got it. They go out, we got 50% of the, OK. So you say, OK, well, wait, there are also shared PTR and weak PTR. And there is the thread safety that you have to consider. And they say, are you sure? How much more do we have more for the exam? Well, you have a bit more. You have just lambda expressions with capture by value and capture by reference. C++ 14 generic lambda, C++ 14 capture expression. And then you have some to cover some of the std containers, algorithms, function objects. Maybe a bit about templates. The basic templates, type and non-type templates, variadic templates. Because they need to know how to forward parameters like we do in make unique, make shared. I want them to understand how make unique works. So they need to know how variadic templates work. And maybe we'll do some specialization and forwarding reference. Remember the T double ampersand? Remember? forwarding reference, we have to talk about that, and SFINA and STD enable. And if we have time, maybe STD thread. So in Tel Aviv University, it's a non-mandatory course for the third year. I do STD thread here. It's a second year course. I do not reach STD concurrency. But yeah, you have enough till then. So how is it to teach C++ 11? Well, it's more material that we had in the past that makes our lives easier in one way, because smart pointer is good, but complicates them in all new ways. And you're not even supposed to use new. But you still have to know new and delete, right? Last important note. It's almost a new language. So you have to make sure you update your resources and bookshelf. Do that. Thank you very much. So, Meir, I think that I have 5 minutes for questions.
Before just a comment about auto, but I can't stand up. Can I stand up for a minute?
Yeah, stand up.
Because I want to turn around as well.
Oh, you also have a shirt. OK. Grandma, I will read what Meir's shirt says. Grandma, I don't use new and delete in my C++ code anymore. Whoa, that's great. I wrote that. OK? I prepared the shirts for the conference, so I like it as well. And there is one also, don't auto me. I'm a person P. Any other question?
Yeah.
Daniel.
Someone who's not teaching C++ on a daily basis, do you think that today we still have to teach the old-fashioned C++ as an extra to the new one? Or should we just teach it, or are we going to teach only the new stuff? And like, because the old ones, old things are not good anymore.
So the question Daniel asked, with the new features of C++, do we have to teach the old features? I would add to it, do we have to start with row pointers or start with smart pointers and then maybe later on open under the hood and say, you know, there is a pointer underneath? So the question is where to start with char star or to start with stud string? Now, there are many answers for that. And for this, I recommend you to go for Kate Gregory lecture given, I think, several times in CPPCon on stop teaching C, which means when you teach C++, teach C++ and stop teaching the C parts of C++, teach students how to use smart pointers or not, how to use pointers, etc. It's a good approach. It's not exactly what I'm doing. I do, here at the Academic College of Tel Aviv-Yafo, we start with C on the first year. So after they know C, and I go to smart pointers, I have to explain in a way what is a smart pointer, and they understand it by comparing it to a pointer. So I do start from the basic. But it makes sense that if you start with Java or start with Python, and then you go to C++, maybe you do not have to start with pointers. You can start with, like, for example, when we use file, use an object to work with the file, we do not go to the operating system, or maybe in another course, to understand how file works. We just use the high-level mechanics. So again, with pointers, we can use the high-level mechanics. Same thing with strings. And this is the argument that Kate Gregory takes in her lecture, and I recommend watching it. It's on YouTube. You can find it. Any other question? Please.
Maybe a couple of words. What's your opinion about the difference between teaching people who don't know C++ at all and teaching co-workers who actually program in it in some capacity?
OK, so the question was the difference between teaching a beginner, teaching someone who do not know C++ at all, but I guess know maybe C.
Familiar with programming.
OK, familiar with programming, as opposed to compared to someone who writes C++, your coworker, your colleague at work will know parts, know something about C++. So I would say that when you work with someone, you go to the actual examples in code. You start coding, you do things, and then you explain, OK, we're using here shared PTR because shared PTR gives you these abilities. And you go, in a way, top, bottom. And my approach in some of the cases is to build things bottom up. But still, when you teach juniors, you mix it. You do some bottom up because you want them to understand how char star creates a string. This is my approach. Even though Kate Gregory would say start with std string. Okay? On the other end, there are things that I would go top, bottom. So I think that the mix would be that with a coworker, you would start top, bottom, because the top is what the assignment, the task, what we are going to do. You usually do not understand every bit and byte in the code of the company. You just call a method, and it should do the work, we hope. On the other end, in an actual course, you do want them to understand what is going on beneath. Thank you very much, all. Another question, last one.
Just if you can tell us as lecturers, how many semesters of C++ you have when you're talking about you're teaching C and then C++, and when you teach everything?
Yeah, so first of all, we will have later today a panel about teaching C++. Iris will lead the panel, and we have several people here in the audience who would be sitting in the panel. So you will have your answers, and I will have my answers. And here at the Academic College of Tel Aviv-Yafo, they have first year learning C, 2 semesters, and then they learn C++ on the 3rd semester, on their 2nd year. In Tel Aviv University, they switched. In the past, they learned C++ as a mandatory course. Now, in many institutions today, not only in Israel, C++ is gone, is up at the attic as a non-mandatory course. There is a very old blog post on that by Joel Spolsky. Have you heard about Joel Spolsky? He's known now as being the co-founder of Stack Overflow. So Joel Spolsky has a very old post on how it is called, the perils of Java schools, right? And in a way, mock, in a way, the institutions that go with Java. At the end, it's only programming language. It doesn't really matter where you start. And he says that it does matter, because if you start with the difficult things, then you get the good programmers. And it's not that you will, at the end, necessarily program in C++. It might be that you are going to program in Java. But you will be a better programmer if you get the challenges. And C++, as you see, gives us some of these challenges. So I don't know. I believe that C++ is important because you understand things. Here we have many graduates who go to the C++, to the industry with C++. Some of them sit here. And I think this is important. Thank you very much. I think that we have a 10 minutes break, right?